Okay, I start a little bit on this. I'll continue with this MFR in series. So we were at calculating the volume 2 just now. You have to bear in mind that for conversion, in order to get the conversion that happens after reactor 2, okay, because I said the conversion after reactor 2 is representing the conversion that happens both in 1 and 2. So meaning that your calculation has to start with FA naught. Okay, sebab X2 ni dia calculate untuk these two reactors kan. So dia punya calculation adalah the flow, the inlet has to be FA naught and the outlet has to be FA2 over inlet which is FA naught. So FA2 you dapat begini, so you akan masukkan dalam FA2 here. So just now we calculate FA1 as FA naught minus X1 FA naught. Okay. So ni FA1 ni you akan masukkan dalam this FA1. So bila you simplify, V2 you akan dapat macam ni. So how do you calculate V3 then? Okay, saya padam dekat sini sikit. Dan saya padam sini juga. Okay, so V2 just now you dapat V2 adalah FA naught. After simplification you akan dapat FA naught over negative RA X2 minus X1. So term ni, this equation, this theory is actually representing this graph. So kalau you tengok yang warna biru ni adalah dari X2 ke X1. I mean X2 minus X1. Betul tak? Yang dekat sini. Kan? Kemudian dia akan didarabkan dengan FA naught over negative RA. So dia adalah representing this square. Okay. Now let's have a look at how to calculate V3. So V3 yang ini dia adalah FA2 minus FA3 RA3. So just now I mentioned that RA1 is equals to RA2 equals to RA3, which is equals to RA. Okay. So kalau in terms of conversion, FA2 tadi kita dapat FA naught minus X2 FA naught. So the same thing for FA3 is FA naught minus X3 FA naught. So you masukkanlah FA2 masuk dalam ni, FA3 masuk dalam ni. So bila you simplify, you akan dapat FA naught negative RA X x3 minus x2. Okay, so V3 ni dia juga represent this square. Okay, you tengok dia adalah x3 minus x1 darab FA0 over negative RA. Dia adalah representing this square in red. And I like to emphasize here that if just now, kalau PFR in series, we can regard that as one or single PFR, a long PFR to represent 3 PFRs. Ini tidak sama dengan MFR in series. Sebab kalau you buat kalau you nak samakan dengan PFR macam tadi, katalah you ada graph, kalau you nak samakan single MFR yang besar bersamaan dengan 3 MFR yang in series, memang tidak sama. Sebab kalau MFR yang besar tu dia adalah the whole square of this. Maksudnya volumenya adalah lagi besar ni, volume yang the whole thing ni adalah lagi besar berbanding V1 plus V2 plus V3. So you have to bear in mind that low volume is economical compared to high volume. So that's why kalau untuk MFR in series, you really need to calculate the area of square based on its square. You tak boleh terus jadikan satu square besar macam tu, sebab the calculation in terms of cost wise is totally different. So dia tak sama dengan PFR macam tadi. Okay. Okay. Nak masuk sikit dekat kalau you have MFR in series, MFR in parallel. So let's say parallel, you ada flow, kemudian dia berpecah. The pipeline is, dia berpecah begini, dia punya pipeline. And katalah the volume for every MFR in parallel is equal. Lepas tu the single reaction happens at the same temperature and you ada the same initial feed rate. So bermakna X1 conversion that happens in reaktor yang atas ni adalah sama dengan reaktor yang dekat bawah ni bersamaan dengan reaktor ni. Okay, that is the information that you need to know. Okay, for that I like you to try, let's say, to find the exam question for MFR in parallel dekat April 2009. Boleh juga tengok dekat buku Fogler page 74 kalau third edition ni. Okay, and page 241 for MFR in parallel. And with that, we continue with the next video.